Okay. Hello and welcome to my session, Architecting vSAN for Performance. Who I am, this is the official disclaimer. I've done this agenda for today. So introduction, going to give you a quick over the use cases, the different use cases and different customer situations. And then we're going to start and kick in with the design considerations. Design considerations for vSAN, starting with cluster, disk groups, and then the most important part, the I/O controller, the caching tier, the capacity tier, the network, and then, shutting the session down with performance measuring and recommendations. Who I am, my name is Marc Huppert. I work for a computer center in Germany. I'm doing the VMware stuff since 17 years right now, every day. And sometimes my wife mentioned to me 7x24, so I'm really addicted to it. And as you can see, I'm an instructor too. And yeah, it's got all the several certifications as well. And I have done personally more than 100 vSAN implementations within Germany at several customer sites, from really small installations from ROBO sites up to a really huge stretch cluster implementation over several clusters. So we're talking about several use cases. VDI, actually, I'm working at a customer site in Germany, in Munich, who's going to virtualize 3,500 desktops, and their main decision was to do it on vSAN and not on traditional storage. This is one of the hugest projects right now in Germany. Test dev environments, we have customers who are using extensively the cloning functionality or staging. Robo, very interesting for German customers. I have one customer who's going to do 60 remote locations with vSAN Robo right now, and another customer with 90 Robo locations. All of them are using 2 hosts at the Robo site, and then one witness host, one witness appliance within the main data center. Management cluster, also very interesting part for several customers who, more and more customers who invest in dedicated management clusters for their vSphere environment. That's also a good choice. Disaster recovery, disaster avoidance. We have customers who have their traditional shared storage, most of them, most of the time fiber channel, working at their main data center, and now they're going to invest at a second or third data center location, and they just want to get rid of the traditional shared storage, and that's the reason why they are investing in vSAN as well. And then DMZ, always the first part at a customer's situation and discussion, that's the easiest part to start. But most of our customers using business critical applications on top of their vSAN implementation. So that's just the basic marketing stuff. Now digging into design consideration. Let's start with a cluster. There are several discussions about clusters. What are the size we're going to start? Will it be a minimum a 3-node cluster configuration? Will it be a 2-node configuration? Especially a 2-node configuration where you have dedicated requirements for 10 gigabit networks, even if the Robo instance is running all flash. What about the fault domains? And this is my list that I'm going to discuss with every customer. If the customer decided, okay, we were going to do a 3, 4, 8, 16-node configuration, whatever, or just a 2-node one, what about the fault domains, the REC awareness within their environment? What about stretch clusters? We have customers who avoided the enterprise license, who's going to start better with the advanced license, and is going to operate each data center completely separated and replicate virtual machine asynchronously between the data centers to avoid the enterprise license. What about maintenance mode? And some customers are really looking at me, you're talking about maintenance mode before starting a project? I say, yes, because what are your normal operations when doing maintenance mode? Are you going to do a full data migration? Are you going to ensure accessibility? That's things we have to discuss. And then always each customer wants to have deduplication and compression discussions. Can I use it? What about the factor? And I would not calculate with more than a factor of 3x. It heavily depends on how many SSDs you have within your capacity tier. I'm going to talk a bit about that a little bit later. And then the encryption part. Especially in Germany, many customers want to have encryption within their environment. environment. So we need to think about a dedicated KMS cluster to create without using vSAN, without using the encrypted vSAN. It has to run on a dedicated platform, on a dedicated data center or whatever. But it has to be highly available, so it must be a KMS cluster. So these are the first steps. And then we're going to dig a little bit deeper into, the disk group design. When talking about vSAN, you can have 5 disk groups, and each disk group can have 7 capacity devices, so up to 35 devices. The question right now is, should I go with more disk groups or less disk groups? It depends. When using more disk groups, you can get even more better performance out of your system. You could tweak a little bit the configuration with the stripes that can be configured, but multiple disk groups reduces your amount of dedupe and compression ratio. That's the problem behind that. And you're going to need an additional caching tier device for multiple disk groups. That has to be in mind. And now the heaviest part that depends on performance, the I/O controller itself. Always, 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 always check the HCL first. And check it on, for this example here, Cisco environment, check it for pass-through or RAID 0 configuration. It heavily depends on your later performance. And then check for the QDEF of the controller. If it is too low, it's going to get not into the VMware HCL, especially when running vSAN at home lab environments with the setter controller. And then check for the supported versions. There are I/O controllers inside the HCL that are not supported for the latest version. Their support stops on 6.0 or something like that. And the storage controller, it is definitely preferred to have pass-through. It has 2 reasons behind that. The first reason is, what happens if a device fails? With pass-through, you can remove it, you can attach a new one, and you just can change your vSAN configuration within the web client. With the RAID 0 configuration, your I/O controller, it has an influence onto performance. I'm going to show it to you in the next slide. The main problem is when replacing a device. With RAID 0 configuration, the device is defunct, you're going to remove it. You're going to insert a new device, and then you can't do anything. Because you need to create a new RAID 0 configuration, get rid of the old one, and then go into web client and add the device again. Within my home environment and at several customer situations, we have to use RAID 0 because other devices are not supported pass-through configuration. So this is a screenshot I always use for LSI devices, the store CLI command line. Within store CLI, you could create RAID 0 devices within ESXi and then easily attach it to the web client. The main part is, if you're going to do a vSAN hybrid, there will be a different configuration than do an all-flash for the I/O controller. Especially, there is, for a magnetic disk, read ahead configuration must be configured within the RAID controller. For an all-flash configuration, no read ahead is the option that must be chosen. There is an KB article from VMware where you can also read this. And then there's sometimes strange configuration when coming to customer sites where the customer have created their own vSAN implementation. The problem with that is, in 99%, the customer is going to use vSAN and non-vSAN disk attached to the same controller. For example, RAID 1 configuration for the ESXi binaries, and then the other disk attached to the same controller used for vSAN. It is officially not supported. There is a KB article. If you enable a customer improvement program and the online health check, you're going to get to this knowledge base article. And at the bottom of this article, in a worst case situation, this scenario could also lead in data loss inside your whole vSAN cluster. And we have seen this configuration at one customer site is going to lose all the data. And then opening a ticket, and the support mentioned, hey, what are you doing there? It's unsupported configuration. Don't do this. The host design, especially memory configuration. If you have more than 512 gigs of memory inside your ESXi host, it is not supported to boot from any kind of USB device. You must have a dedicated SATA DOM or SSD or any kind of device, not USB, no micro SD or something like that. If you have the configuration, for example, the customer starts with 512 gig, everything is fine, and then upgrade their memory environment. You could extend your core DOM partition onto their systems to get a little bit out of this strange situation. Normally, when planning the design, just choose a dedicated boot device. Now the fun part, caching tier. We always prefer the fastest available device as a caching tier. In the past, we used Fusion I/O cards at our customer environments. Today, we're going to choose only NVMe as a caching device. And you need to check the HCL with the dedicated string of your device. Not each Intel P, for example, P3700 NVMe device is on the HCL. You have to check it with your dedicated device number, and then check if the system is supported for all flash caching or hybrid caching. What about the caching tier? For all flash, the recommended size is desired by IOPS and predicted workload. So what's your use case? VDI, DMZ, it depends what you can use as a caching device. We always recommend NVMe 800 gig or 1.6 terabyte. Within the vSAN environment, only 600 gig is actively used. The rest is just for endurance. And if it's not possible to use this dedicated device, choose write-intensive enterprise SSDs. I have seen vSAN installations at customer sites where the customer is going to use consumer-based SSDs. 3 months, the whole SSD is going to defunct. All areas have wear outs. You can't throw it into trash. Don't do that. Choose enterprise SSDs. For hybrid architecture, we have this 10% projected storage capacity. Choose high-endurance devices, NVMe or maybe mixed-use enterprise devices, because within the hybrid mode, each node could only serve up to 40,000 IOPS per second. For example, I mentioned we always recommend NVMe, and I have here the specifications for the P3700 from Intel. If you choose 800 gig or 1.6 terabyte, normally vSAN All Flash consumes only 600 gig, so why should I choose 1.6 terabyte? It depends on the IOPS you want to achieve. The 800 gig version just support 90,000 IOPS. The 1.6 terabyte supports 150,000 IOPS write. And within all flash, we're talking about write buffering within the cache tier. So choose your appropriate device. That's the caching tier. Now the capacity part. What should I choose as a capacity part? Within an all-flash configuration, you can choose read-intensive SSDs, and we have really good decisions about the 2 terabyte model with 1 drive write per day. It is okay. You should calculate with a device of 0.2 terabytes written per day. Within a hybrid configuration, 1.2 terabyte or 1.92 terabyte as a capacity device. It depends. We have one customer installation where the customer is going to use vSAN for disaster recovery at their second data center, and this customer is going to use the 6 terabyte SATA disks for their capacity. It works as well, but within a hybrid environment, you have this 30% and 70% ratio within your vSAN environment, and that's the reason why we recommend to this customer NVMe 2 as a caching device, even with these huge 6 terabyte hard disks behind it as a capacity. Again, check the HCL. I've done it here for my environment at home. I'm going to use the SanDisk 2 terabyte SSDs, enterprise SSDs, as a capacity tier. As you can see here, all flash, it is supported as a capacity tier on the latest version of vSAN 6.6.1, which is here included in 6.5 Update 1. So now we're going to talk about the network consideration. Forget 1 gigabit, forget it. you have to use 10 gigabit connections for all flash or large hybrid environments. I have colleagues of mine who's going to use hybrid and all flash configuration inside their home environment. They're going to use a 1 gigabit connection, but it's always the bottleneck within the environment. Separate the network traffic. You could do it inside a distributed switch. If you're going to buy the vSAN license, you got a VDS license as well. So you could easily implement a VDS. And within VDS, you can configure network I/O control. If your network card, 10 gigabit, 40 gigabit, whatever, is not separated just for vSAN traffic. Within my environment at home, I'm using the Intel NVMe as a caching device and the SanDisk as a capacity device. I started with 10 gig and now replace it with 40 gig. Sometimes customers are really laughing about it. My home environment is 40 gigs. Most of the customers does not have this. It is not really necessary, but I want to get the most possible performance out of the system. That's the reason why I tweaked it to 40 gigs. Now it comes to the performance measuring part. The real fun thing about that is we have the HCI bench. Let's call it official fling. The HCI bench you can use, you can implement it. You have virtual machines that is going to be deployed, and within these virtual machines you can set up the test environment. And I highly recommend that they're going to use HCI bench 162 within vSAN 661. Especially there's a special integration. When you're going to start your benchmark, for example, just with 4 VMs, and you just, let's say, get 40 to 50,000 IOPS out of your environment. And when you use HCI bench 162 with vSAN 661, you're going to get recommendations to increase your number of VMs or increase your number of disk files per VM to get the most possible performance out of the system. When you see it here, 203,000 IOPS and nearly 800 megabytes per second at a write latency of 4.67 milliseconds, you should always consider warming the cache. Within HCI, you could use random 0, you could use 0, or you can choose none of the warming the cache within vSAN. If you have enabled DDoP and compression, you should highly recommend to choose the random preparation for HCI bench. You can get the most performance out of the system. I have done it several times at customer sites, and I've also compared the performance from the vSAN to a traditional storage. I just have deployed HCI bench onto a traditional storage VMs onto the same environment. And that's pretty easy. So our recommendations: create building blocks. And this is a real customer scenario we're using for the customer with the 60 remote locations. We're going to start with a small configuration, 1 NVMe device and 5 disks. It's an hybrid configuration. Each host has 128 gigs of RAM. And then the medium configuration, double it, especially for everything, NVMe capacity and memory. The customer truly understands that especially the NVMe device is not cheap, but it is worth it in case of performance. And then the large environments for this customer site, it's not going to use the ROBO sites, it's going to use for their bigger other data centers. We're going to use the large environment of 3 NVMEs, 15 disks, 384 gig of RAM, and especially for the ROBO instances, the version with 2-node direct connect that comes with the previous version of vSAN is pretty handy for the customer. The customer saves nearly about 11,000 euros per remote instance, because they does not have to invest in a dedicated 10 gigabit network environment. So, and one thing we always done at a later part. Normally, we're discussing the project with the customer. The customer is going to buy the hardware. We're going to implement it at the customer site. And then we have these policy options. In reality, we just configure one policy option for the whole customer environment. And later on, 2 or 3 months later, we're going to analyze the environment and it's going to check what kind of block sizes are used, what are the real world performance values inside the customer environment, and then we're going to tweak their environment with policies, especially on hybrid versions where you can use the flash reservations within your caching tier. And that's always the thing that we're going to do after implementation. When discussing with the customer in front of the project, yeah, you can use this option, you can use that one, you can tweak this one. It is buffer overflow for the customer. So implement it, discuss it, implement it, and then tweak it on real-life workloads. That's what we do every day. And choose the right license. So we have always this kind of discussion about the all-flash support. Yes, it is based into the standard license, but every customer who's going to hear about the all-flash, they want to use DDoP and compression. And that's only inside the advanced license available. And if you're going to do a stretch cluster implementation, you need the vSAN enterprise license. And you have this limit to have only 15 ESX hosts per data center, 50-51. That's the limit of stretch cluster configuration. That's it for today. If you're going to have any questions, feel free to ask me, get offline. Yeah, that's it. Thank you.